Example 4.4. Obtain the Thévenin equivalent for the following circuit. Because this circuit has a dependent source, method 1, this is the conceptual method, is not valid. Only method 2 can be applied. So as always, try to simplify the circuit. So always try to simplify the circuit using reduction and transformations, source transformations. So let's do that. So the first thing I see is that, note that I could do a source transformation. So if I do a source transformation, that's because when I look at this branch right here, you could see that I have a source and a resistor in parallel to each other. So if I do this source transformation, I'm now going to get a voltage source that's going to be 2.5 times 6, which will be 15 volts. And then it's going to be in series with that 2IK source. And then I can add the 6 on the 4. So let's be a little bit careful on how we write this out. So then I'm going to go, I'm going to have a voltage source. This is my Thévenin voltage. And then you're going to see here is that then I have my dependent source, which is pointed in the opposite direction. And then I have one resistor, which is then going to be 4 plus 6. And so then I have my 3 here. And then, of course, I have my 1 right here. And all I know is that I have this IX going through that 3K. So I would say that this is not the final form. So the final form is to combine the two sources. So this is how I'll draw it. I'm going to say that this is my voltage source now. So I'm going to do plus or minus. Note that the 15, I'm going to assume has the right polarity. So it's going to be 15 minus 2IX. I have one resistor, which is now a 10 ohm. And then, of course, I have my 3 ohm. And then I have my 1 ohm. And this is A, and this is B. So this is my circuit here. Okay, so this is the circuit that I'm going to deal with. So I'm going to copy this because this is the circuit that I'm going to need. So now I have my circuit, not this one, not the original one, this one. So now let's go look at this guy. Maybe I should say this. This is our circuit to solve. So here we go, step 1. determine VOC. So note that if I look at VOC, right? So here's this guy. So I'm going to say that this guy right here is my VOC, and you could see that this resistor is a dead resistor since it's in an open. So this guy's gone. There is no 1 ohm resistor. And I know that this guy is IX. So right away, you could see here is that VOC is the same as a 3 ohm resistor. So that means what we're doing here is that we're solving for VOC, but that's the same as the 3 ohm resistor. And note, again, there's only 1 loop. So if I look at this loop, you could see that this loop is going like this. So that means here is that this guy has to be 3IX. So I know this is what I got to do here. So if I can determine IX, I now know immediately what the VOC is. So let's go do that. So I'm going to apply KVL. Solve for IX and then VOC. So if I look at that thing, here's my circuit. So if I look at that thing, you could see that KVL tells me what? It says, so if I'm going in this direction, I'm going to find that I'm going to get what? I'm going to get 10IX plus 3IX has to equal 15 minus 2IX. So now if I solve for IX, I'm going to see here that IX, right, you're going to get, you could see that if I bring the 2, it's going to get 15 and, excuse me, 15IX. It's going to equal to 50. So that's got to give me 1 milliamp, which then tells me that VOC is 3IX. So it's going to be 3 volts. So now the next thing I have to do here is that I can determine a short circuit. Yeah, I got to determine a short circuit. So we want to be careful here in calculating VOC. IX was equal to 1 milliamp. But this is a different circuit. But this is a different circuit. And one cannot use IX equal to 1 milliamp. You can't do that. This is a brand new, fresh circuit. So what we need to do now is that we need to place a short across the open. So let's go look at that. So here's my circuit. So if I look at my circuit, what I'm done here is that I know that this guy is IX, and now I'm going to place a short right here. Now note that that short is also the current of the 1 ohm. So what I want to do here is that I want to rearrange my circuit so that I mean, I don't have to rearrange it, but you could see here is that the 3 and the 1 are now parallel. So now what we're going to look at here is that I'm going to say that note that the 3 ohm and 1 ohm are in parallel. So what I'm going to do here is that because they're in parallel, that means that the voltage of the 3 ohm has to be the same as the voltage of the 1 ohm. But there's a connection between these two, because now I know that the 3 ohm is 3Ix, and I know that the 1 ohm is 1 I short circuit. So what I'm going to do here is that I'm going to convert the Ix current into, V3 ohm voltage, which allows me to simplify the circuit even more. So if I do that, here's what I'm going to get. So I'm going to get 15 minus 2Ix and then I have my 10 ohm resistor, and then I have this resistor right here. So this is 3 parallel to 1. Of course, this is 10. And you could see here is that if I compute that, this is 3/4 of an ohm. So now I'm going to say that this is the voltage across the 3 ohm. It's really the voltage across the 3/4 of an ohm, but just using notation because we know that they're all the same. So now what I'm going to do here is that I'm going to use VDR. So I'm going to use VDR to get V3 ohm. So if I do that, this is going to be V3 ohm is then going to be the same as 3Ix, which is then going to be what? So it's got to be 3 parallel to 1 plus 10, 3 parallel to 1 times the voltage, which will be 15 minus 2Ix. But I know that Ix is really 1/3 I short circuit. And I probably should have made this a little bit clear here, but Ix here is 1/3 I short circuit. I should have really labeled this earlier. So then this converts the calculation. So now this really becomes a circuit that reads like this. I short circuit. And then again, I know that this is 4/3 plus 10. 4/3. Ooh, is it 4/3? No, it's not 4/3. It's 3/4. And then this becomes 15 minus 2/3 I short circuit. So you could see I have one equation and one unknown. So now I solve this for I short circuit. And then when I do that, I get that I short circuit is 1 milliamp. So here we go. So if I come back up here, let me grab this circuit right here. And if I look down here, I now know the Thévenin resistance, the Thévenin resistance, and equivalent circuit are, I know that RTH has to be VOC over I short circuit, but this guy was 3 volts, this guy was 1 milliamp, so this becomes a 3 kilo ohm Thévenin resistance right here. So now if I look at my equivalent looks like this. So now I can replace this circuit with with a Thévenin voltage that's equal to 3 volts. I have a Thévenin resistance, which is 3 kilo ohm. And so this is my circuit right here.